Today, our main topic is going to be state machines. And we start state machines and the software associated with a state diagram. So the first part of our state machine and the state diagram will be in the idle state. In other words, nothing is going on with your washing machine, which is our application, and no buttons have been pressed, and you're not ready to go. It's all right? So, how many of you have used a washing machine here in the U.S. that is based on buttons and has LED or LCD controls, as opposed to the one with the dial where you press in? Raise your hand. Ooh, that might not be that many people familiar with that. All right, let me step back. How many of you have used a washing machine here? I'm sorry, not a washing machine, a dishwasher here. How about a dishwasher? All right. I'm trying to think of another thing that might have a state machine. A vacuum cleaner? Microwave. Microwave. Let's do a microwave. All right. We're going to do a microwave. That might be a little bit too easy. That's going to be too easy. You know what? I'm going to go back to a washing machine, and you know what? You're smart enough to know how an embedded system-based one is going to work, right? So we're going to identify the functions of our washing machine. Before we start with this, let's see what wash. Right? So, another step before. It's got to fill up, right? Then there is pain. Then there is and then what comes next? Spin. The assumption is as it spins, it's also going to drain, all right? And we'll make it simple. I mean, some washing machines, they have 2 rinse cycles, some 2 wash cycles. But we'll make this such that at a later time we could worry about that, okay? Now let's think about this. So these are our functions, right? Let's take a look at what our inputs might be. Okay. So our inputs might be hardware, processing. So what would that be? Well, think about a washing machine. What's really important in a washing machine to keep it from getting too much water in it? All right, some sort of water level, right? Somebody also I heard said timer. That's another good one. What else? By the way, water level, both high and what else? Ooh, temperature. What else? Speak louder. Do you think that's going to be a sensor inside?
No, it's like the select that when you're...
Oh, buttons you're saying. All right? So we'll... Let's see, what else do we have? Well, we'll just do type and temp at this point. Oh, type, temp, time. What else? Ooh, load. And actually, in some of the more recent washing machines, how could it tell that? It's sensors with respect to it's turning a motor, and how easy is it for that motor to turn given a certain amount of energy. So in other words, what? It's measuring torque or something like that, right? No, and the speed, right? So we'll also say the, I'll be a separate one, we'll call it speed. Ooh, this is starting to get complex, isn't it? Anything else? Oh, lid, door. Open or closed. All right, I think that's enough. So, part of this is to identify how are you going to do and have a diagram, right? So, let me start this diagram, and then I'm going to make you finish it. And this will be a very good opportunity for a quiz. State. What would cause a transition from the idle state to the fill state? All right, well, we have a start button. And what else is important? The water level? You're going to go from idle to fill with a water level sensor saying high? That means your door could have been open and water would be sitting in there. I'm talking about a front loader now, all right? Water would be in there kind of like, you know, the Force from Star Trek or Star Wars or something, and nothing comes through it, right? You have to make an assumption that the water level sensor is going to be all the way down, because otherwise you wouldn't let it get in another state where you can open it up, right? What else would other change it to the fill? All right, the lid closed. Anything else? Do you care about a timer to go from here to here? So, by the way, something's going to happen in the fill state, isn't it? That will cause you, for certain things to happen, like valves to open and stuff. Notice I say that's inputs. I don't say anything about actuation. In other words, opening up valves and stuff like that. All right, I'll do the next state. We'll move from the fill state to the wash state if what happens? All right. Level equals full. Or let's see, we'll call it that sensor. We have to worry about a timer? Not really, right? Do we have to worry about a temperature for changing states? No. Pushing a button. Oh, you can have to push a button somewhere when you're in this state to move from this state to this state. Oh, so maybe the button is going to be something that's processed later. not that's going to cause the transition between states. The load, it also kind of depends. Let's say no, let's make it simple, all right? Speed? No, probably not. Door? All right, now I'm going to have to make a rule here. I'm going to assume that in all of the situations, once you go into this state, the door is locked and will not open until some other state where you drain the liquid out occurs. Okay? So, your next, so in other words, there it is, water high. That's the only way. I'm going to have an out to this. I'm going to say, yeah, there is a button that will take care of everything, right? And I'm going to say there's a button here called drain, or there's a drain. There's a state here called drain, and you'll go from this state to this state if you press a button that says cancel. From drain to idle based on water load. Does that make sense? So in other words, I don't care how soapy my my clothes are, because I'm putting detergent in that separately. I don't want to open that door until it's been drained. If I hit that cancel button, I will drain it and then let it be opened. Does that seem reasonable? All right, so now what I want you to do is spend a few minutes and finish this. Do you want to do it in groups of 2 or 3? All right, that'll be interesting in 3 because that means there's some groups of 4 that you're going to have to split up, right? So I'll allow you in groups of 2 or 3. Go to it. And so here's this is not what I want to put up here. That's what I want to put up here, yes. So here's all the data that I put on the screen, a little bit easier, so I'll be able to scan this. The functions, input the microcontrollers. There's 2 fills, 2 drains, 2 agitates. So I guess the question really comes down to, does that mean those fills are 2 different states or 1 state? And, look at the microcontroller, which of those would cause a change of state? So I would say everybody here identified 1 drain state. And everybody here identified 1 agitate state, or maybe 1 person did not. So let me show you how I would do this. And then you'll look at it and you'll get really sad. Now here's a question. Is there anyone that is particularly wrong? There's many ways to design a product. The question is the way you design it easy to program, implement, and later debug? Because the big problem comes later is how are you going to debug this or verify that what you're doing can be maintained by somebody who didn't write it in the first place. In my opinion, I'm going to say this is probably the easiest way to do this. First of all, we start with the idle state. And you always identify the initial state when you first power on. Now, we did initially say that we're going to have the fill state, right? And we said you would go there based on the start and door closed, right? And there's obviously, you're going to stay in the state if that is not done, right? But I'm not going to put that detail in there, that'll be assumed. Then we identified a wash. And I'm going to call this, I'm just going to call it wash, all right? And the way we went to this was water high. I'm going to do the following. I am actually going to create another state, drain W. And the way you would go here is based on a timer. And the timer is going to be based on whatever your button presses were. So remember I said here, you have buttons, type of close, temperature, time, dirtiness. All right? So dirtiness is going to be associated with, is this, let's see, in my washing machine I have regular, soiled, whites, and sanitary. And when sanitary runs, it goes for 2 hours, which is amazing because it takes that long. It has like multiple rinses and all this other stuff going on, all right? So, drain W. And then what did I say next is, maybe I should do fill W here, right? And this next state is going to be, fill rinse. And then I'm going to have drain rinse. Nope. It's going to be what I'll just call the rinse cycle, right? And then it's drain rinse. And then I'll have spin. Now what causes something to go from spin to idle? All right. Which one? You want to do a timer? Or would you rather do something associated with the load sensor? In other words, when you have water in clothes, it's very heavy, and it will identify that it's a heavy load. But as you spin, the centrifugal force pushes the stuff out, then suddenly it gets easier for that to spin. So what do you think?
If you user wants to pause certain amount of time.
All right, we'll make life easy for our design. By the way, what else will identify a timer? I think right here, right? By the way, this is really tough to read, isn't it? All right, that looks a little bit better, doesn't it? Oh my gosh, what just happened? It was a very sticky button. All right, let's stick with that. Going from drain to fill rinse, what would that be? Water low? Going from fill to rinse, it would be water high. And drain to spin would be water low. Now, even though this is, we'll put this in the middle. Oh yeah, you have to give the opportunity that whenever cancel is pressed, no matter what state you're in, you will end. even though in this state right here, and I will call this water low, wow. Now, compare that with this one. Is this accurate? That's interesting. Is this right here an input? Or is it a setting? Or is it a previous state? It's kind of like some previous state somewhere, right? And let's see, I'm trying to find another one with an example. Is that complete? Seems to be a bit incomplete, doesn't it? Say it again? Oh, there's no rinse. Oh, that's even worse. Actually, here's one that's rather interesting. So now here's the question, all right? So I showed you some examples. I showed you mine. Which one do you think might be a lot easier to program? The answer is mine, right? Now, one thing that might make people a little bit scared is you look at this and you say, yeah, but you have a lot more states. And the answer to that is, so what? Is this clear? Is there a single input that will change you from one state to the next? Well, what is this? A button, or a button and a sensor, right? A sensor, an interrupt based on the timer, right? A sensor, timer, an interrupt based on a timer. A sensor and an interrupt based on a timer. Button, and another sensor. Everything, every change in state is associated with an input and not a previous state. So this is one example that I can give you for saying, oh, that would be great. Let us look at using that, all right? So for all the future designs we're going to do today, I want you to rely on this being this state diagram, all right? And how am I going to review these state diagrams that you did earlier? I don't know. Should I be really mean and take off lots of points? No. Okay, great. All right, so let's take a look at what we said that we would do. Now, let's look again at this. What is going to serve as an input or as some information that would be useful? Let's see. Water level high. Water low. Water high. These could be based on interrupts. Yes or no? All right. Now you can continuously poll these, or you can rely on them generating a digital signal when a float or something like that gets low enough, or a float gets high enough that it triggers that. Should we go with that? All right. So we'll say that this is an interrupt based. All right? Timer. So, you know what? We could set the timer to pretty much anything, right? So, is this an interrupt? Always better to be an interrupt, right? Temperature. What do we want to measure for temperature? The water coming in or the temperature of what it is inside? All right. Water coming in? Okay, so that we need a temp. We'll just say temp. All right? Is that an interrupt? Yes or no? Oh, come on. You gotta say one or the other, all right? Who votes it's an interrupt? Who votes it's not an interrupt? All right. It's not an interrupt. And I agree, it wouldn't be good. Button. Oh, there's lots of them, right? An interrupt? All right. And I think we said we'll call it dirty, we'll call it close, or type. And do we actually want one for time or, let's see, what was my other thing I said? Temperature, time, and type. Cancel dirty, type. Oh, what temperature you want to do this? Are these going to be interrupt buttons? Are you sure? Button start. Is that going to be an interrupt? We'll say yes, just for grins. All right, let's look at some of the other inputs we have. The load sensor. We may or may not use that. Interrupt? No. Speed? Interrupt? No. Door? Sure. We have so many interrupts that we have available. All right, I'm going to say no. You don't have to have it as an interrupt. All right, so now let's look at these are our inputs, right? Now let's look at our actuators. What are you going to control? The hot water input and the cold water input, on and off. The pump that will pump water out, that's for draining. Our general motor to spin. And I'm going to have a door lock. How about that? All right. Is there anything else that you think that we need that is an actuator or something you'll control? What have I missed? A what? Motion detector? To make sure the thing doesn't dance? I mean, is that something we want to add? Yes or no? All right, we're going to make this simple. We'll say no then, because you said no. Anything else I'm missing? Not that you could figure? All right. Now, this is a state machine, right? So we're going to have an enumerated variable called state. And so we'll identify each one of those states up there. Notice they all have a different name, right? Fill W versus fill R. Drain W, wash, rinse, drain R. So, and just plain old drain, all right? So we know that we're going to create in our state machine a couple of different, a state machine that will allow us to go from one place to another. Now the important thing to think about this is, how do you change states? So let's look at a really easy one. Is drain, right? So in the state drain, what is happening? All right, so in the drain state, and I might actually just do it on a piece of paper, because that's probably going to be a little bit cleaner. All right, I set down my glasses, and where did I put them? There they are. I hate when this happens. So I'm going to be in the drain state. And so it'll be a function called drain. And there's no input. And I'll stay in the drain state, but what will I do in the drain state?
Actuate the drain pump.
You do what?
I actuate the drain pump.
Okay. Pump equals on. All right, what else?
Wait till water level.
Okay, so we said the water level is an interrupt, right?
That's it.
That's it? That's interesting. That's it, right? So we are in this officially drain, and we know that we're always going to be worrying about nothing more than turn on the pump, right? So now that means we need another interrupt, right? So let's think about this. We have what is this called? Water low, right? So and this is an ISR, so so I'll just put ISR underscore water low. Boy, I really screwed that one up, right? And so we will enter this when the water thing is low, right? Do you agree? Okay. So what do we do? Well, here's the thing. How many situations does it happen that when the water low, where do you go? All right, well, what's the first thing when I hit the water low, what's the first thing I'll want to do?
Check the state, which state you are in.
What's the very first thing I really want to do, though?
Close the pump.
All right, turn off the pump, right? Then what do we want to do?
Check the state.
All right, so if state is equal to this. Drain W, right? Then we're going to set state is equal to fill R, correct? Else if state is equal to drain R, then the new state is going to be equal to spin, right? Else if the state is equal to drain, then the state is going to be equal to idle. Oops. And to make somebody happy over here, I'm going to do the following. If state equal idle, sound beep. All right, does that look nice? You like that? Say yes, say no. All right, yes. So, here is what I want you to do. Each group, oh my gosh. You're gonna make us do work. Oh no. I don't want to do this anymore. I'm done. I'm done. All right, yeah, we're going to do this. Each one of you is going to do an interrupt. Ooh. And you're going to figure out what to do. All right? So, while we pause, I will assign each of the groups an interrupt. And you'll need to pull out your another piece of paper because it's going to be another quiz. All right? We are back recording, and here is what all y'all said. So A, I gave you was the water high interrupt. And so where did we worry about the water high interrupt? Well, we have one here and one here, and that's it, right? So here we have a void ISR water high, and we had the what does this say? Input pump. Oh, so you just created something else. I said pump. You said something else. All right. What does that say? I can't even. Loader. A water. That's called water input pump 0. All right. So turn off the pump, which is good. If state is equal to fill W, so let's go back to our fill W. Then you're going to go to state equal wash. Else if state equal fill R, then state is rinse. What happens if you're not either of those two states? What do you mean nothing?
Only these two states will be calling that only those states.
You're saying the only time that an interrupt with the water high will occur is only when it's in those two states. What happens if there's an error? What happens if there's a hardware error and the interrupt comes up for water high? What do you think?
Sorts of warning, but it won't cause any damage because we are already opening the pump. So
It doesn't have to take any action. It just has to check if the pump is off and it will just leave the loop in.
Okay, so this is a good time to think about embedded systems. If a situation comes up where there's an error, and that's clearly here, if you're not in the fill W or the fill R state, and you get this interrupt, what do you do? Obviously something triggered the sensor, and remember, mechanical things often fail, right? Because this sensor is going to be afloat that may get stuck to the on position. It may never turn off. So what do? I mean, do you immediately cancel?
You make some beep sound or something like that. Something is going on.
You make some beep, but what do? And oh, by the way, what if it's just an anomaly? Right? What if it's just, a glitch or something happened in the process of this thing emptying? Oh, here's the other thing, which we didn't think about. If it's in the water high state, and you change the state, when will the interrupt clear, or when will you clear or not respond to the water high signal as it's pumping out, right? I mean, think about this. If you are pumping water out, eventually it'll go down to the point where it's not triggering this interrupt, or it's not measured as high. All right? This is a simple example. I just want you to start thinking about other things like how to handle errors. So maybe what you do is you keep a counter. And if it comes through 5 times, then you change the state to drain. You drain it, and then you do an error code. That's an option, all right? Now, you're not going to get this wrong because of that thing I just came up with, but it's something for you to think about, right? This one's the same. I like this. Actually, I think only one person got it right. Notice I said it was hot and cold actuators, right? So they just said water input pump 1. They forgot that there were 2. There's 2 valves. Hot valve goes off, cold valve goes off. Oh, so yeah, something to think about for that one. All right.
One question.
Yes?
You have to lock the door if the water is high.
Well, do you have to lock the door before you start filling?
That is this door closed.
Remember, this is a front-loading washer.
Yeah, but the state diagram is door closed, and now we are locking the door. Now the user won't be able to open the door once the water is high.
Correct.
So that should be one of the things that we do in the ISR. We lock the door.
Are you sure? Are you sure you shouldn't do it way earlier? In fact, I would tend to say that the only time you lock the door is going from idle to this one, and the only time you unlock the door is when you go from here to here or here to here. And I wonder if that's what people did there. So we'll see. So, yeah, the timer one is going to be the longest, isn't it? So let's take a look at the timer one. Well, let's see. Motor off. So where are we going from a timer? Timer is wash, from wash, so turning the motor off. Yeah, that seems reasonable. Timer is also here in the rinse. Yeah, that seems normal. And then timer is also this. Yeah, spin. That seems normal too, right? So if the state is wash, then you go to drain. If the state is rinse, you go to drain R. If the state is spin, you go to idle. So what did they miss? So I would add in here, what did I actually call it? Door lock. Equals off. Would you agree with that? Yes? No? Oh.
Previously it was 10 only then.
State equal idle, and in this state it would be door lock equals off. Do you agree with that?
Yes.
All right. Here we have timers and interrupt. Yeah, timer. If state equal to wash, hot off and cold off. Ooh, I should not show your name, sorry. Hot off, cold off, I don't like that. It should already be off, right? State is equal to drain W. So where's the motor off here, right? State equal drain, idle, and then again, motor off. And well, since motor off is there, there, and there, I would have put it all up there, and again, the door lock, right? Let's see what we have up here. State equal drain, off, drain R, idle, even though this is kind of missing something. And then, of course, door lock. All right, I think we pretty much understand that one, right? All right, let's go off to C. C is interrupt, button, cancel. Oh, wow. This really sucks for everybody, right? Well, let's take a look. Wow. Did they really need to do all this? No? Are you sure? Do you care where you came from with cancel? At every instance, in fact, if you again look at the chart, every instance of cancel always goes to drain, doesn't matter where it came from. In fact, you could be an idle. Ooh, or do you?
Except idle.
Pardon me?
Except idle.
Except idle.
If you are an idle, you stay in idle.
Oh. So that's interesting. Oh, what do you know? You did that. So if state equal idle, state equals idle. Right? Else, motor equals off. That's interesting. Pump equals on. State equals drain. There is one problem though. What?
Water pumps.
Water pumps, your valves. Would you agree? Yep. Okay. State equals drain. Am I missing anything else? And this one I think is a little bit too complex, so let me see this. Oh, there may be something else we have to do here. You got to turn off the timers, right? Even though if a timer would come up, depending on how you handled it, well, we'll see in the next one. Say that again?
Will the state drain take care of that? Once you go to drain, do that?
Well, you'd have to do that, right? This one is a little bit too complex, so
Counted for all the buttons, not just the count.
Yeah, but, oh, you did all the buttons. Oh. I don't want to address that. And button start should have been the most complex one. So if state equals idle and door closed, state is equal to fill W. All right? Else display busy. Okay. Now I guess the question comes down to who's going to handle turning on the water or identifying what the washing state is. So there's a whole bunch of things that we haven't addressed in any of these interrupt buttons. So for example, one thing that has not been addressed is how long are you going to run wash, depending on those buttons that were pressed. So this is actually the place to be able to do that. You want to interrogate what the buttons are that you pressed. For example, the button dirty, button type, button temperature, and maybe identify some variables that need to be run later. Like if button dirty, or if button is dirty, or button dirty is yes, then wash timer is equal to 60. If button or else button or else timer, wash timer equal to 30. All right. So in this one should be a little bit more complex than what you have right there. And I'm looking at the other ones. Don't quite really like all those. So one last thing I'm going to have you do. I've kind of alluded to this right now, right? So what I want you to do is to write, everybody is going to rewrite this button start function, right? Because what I want you to do is to identify how long things are going to run. By the way, other functions in here that were not correctly addressed, right? For example, we did not correctly address how you would handle going from which state? Going from the fill R to the rinse, you didn't set the timer. I don't think anybody really did that. Water high was A, and I don't think anybody set any timers, did they? No? So obviously there's something missing. Yes?
Should the ISR be as small as possible and all timers can be done?
Well, think about this. Timer calculate. What you want to do is to avoid doing calculations in an ISR. By setting flags or setting variables, is that taking a lot of time?
Yeah, so in the fill function we can calculate the water level to be that is to be filled. So in the idle we just change the state machine state and we go to all that function.
Well, here's the question for you. What calculation has to be made?
For example, in the fill we'll check what is the load and accordingly we'll set the variable to load.
That's now getting a little bit complex. And at this point, that's not one of our, we didn't go into great detail about what are you going to do with load and speed and door, or load and speed, right?
Yeah, so in ISR it's just trying to just turn off loads, critical loads and just change the states.
In this case, you're just setting a variable with these other buttons. So, you could put it in one place, you could put it in another place, but I'm saying in the ISR, you're setting a variable. You're not doing any calculation. So that could easily be done in an ISR based on those buttons. But now here's another thing up there. We haven't addressed the input of load and speed anywhere, right? So where do we address it? Wow. So maybe we should look at that in our next class when I give everybody something written by hand and we look at all this stuff, right? But what I want you to do is to take 10 minutes, and I want every group to go to one of the chalkboards and to do the interrupt button start. All right, so I'll see you in a few minutes. All right, let's look at this one right here. All right, I believe it could be viewed on here. All right, ISR start. If state equals idle and door closed. All right, that seems reasonable, right? And then you're going to say, all right, if button is equal to dirty, time is equal to 30, else time is equal to 15. That's what I wrote up there, right? If button type, dirty versus not dirty, speed equals high. Well, that's interesting. Speed equals low. If button temp, that means hot is equal to yes, or hot is equal to 1, else cold is equal to 1. So here's a question. What happens if the start button has been pressed and the door is not closed? What does the state change? No. Interesting. The state doesn't change at all. What if the state is anything other than idle? Doesn't change. All right? So this kind of takes care of that, right? And if I saw somebody else here, they said, for this, if else beep. Somebody else said, put a message already started, but I think my washing machine will actually beep at you saying, that was dumb. All right. So yeah, this looks pretty close to what I'm looking for. Notice any computation? No, we're doing is setting variables. All right. And then the state goes to, oh,
It is not changed.
the state's not changing. Who's my workers on this? You're all laughing and giggling, huh? All right. Obviously, there's one last thing missing here, and that is state is going to be equal to, I believe it's fill W, right? And that'll go somewhere in here in the correct logic. Oh, they're running over there and they're fixing theirs, all right? That's all I have for this class. Thank you very much.